In this video, I want to go over the installation of the Sega Game Gear VH1 replacement mainboard. This the mainboard is the 1.7 version. As you see, it's still missing some parts. It's missing the ASIC, it's missing the cartridge connector and the expansion port. Those are parts you need from the original Sega Game Gear. It's a mainboard like this, and you need to pay a little bit of attention that you have the right single-ASIC chip. So this is the chip you need, and you might see it. There should be a marking on the chip. When you read it like this, it will tell you the following. Let me see if we can get it in focus. Readable. There it comes. So the chip, it should read 3155535. If it reads something different, it's not the right chip and it will not work on the main board. So we need to take this chip off and move it to the replacement mainboard. Next to that, I'm also going to take the cartridge slot and the expansion port. For repair reasons, I'm also taking the crystal oscillator, the two ROM chips, and the contrast wheel because they quite often break and I can repair original Game Gears with it. So I will be also taking those off. What comes with the kit, it's also two new cables for the power and the soundboard. It will also come with two screws for the cartridge slot. LED is actually a two-color LED, so it's either green or red depending on the how you mount it. So it's either you can turn around and it becomes green, and the other side it becomes red. A brand new crystal oscillator, and optionally also of course a new wheel for the brightness, and optionally you can take the power board and the soundboard. Since the 1.7 version, I added stereo support to the soundboard. So as you see, it has left and right speaker connection. Of course, you need to make a second speaker fit in the shell. So this requires you to do some drilling and make a bracket or something to hold the second speaker. But of course, when you only have one speaker like the original Game Gear, there is a little switch here. You can say speaker output to mono, and then it just works like the original one. And of course, the power board. So it's a power board made to use a 3.7 volts LiPo battery. It has a USB-C port for charging. And it simply works the same as a original main power board. It only does not have the 34 volts power regulator because we don't need it on the replacement board. So next step is to take the parts from the original mainboard. For the through hole parts, I will be using a desoldering iron. Of course, you can also do this with a manual desoldering pump, but I have this this automatic one, so I'll be using that one. For the SMD parts, I will be using a hot air with a heat plate. Still, I think it will also work with only a hot air, but the heat plate makes it a little bit faster to work with. So yeah, let's start with the cartridge slot. As you might see, it has these two metal parts that actually hold the cartridge slot in place. What I usually do is I use a small nipper and I simply destroy them a bit, press them together, and then I take a screwdriver a Phillips one, and I push those pins out. You can also drill them out, but I think this is the fastest way, what I noticed so far. Yeah, so I will be desoldering it. I have a Weller D680. I think it's a really nice desoldering iron. It's lightweight, goes really fast. If you do a lot of rework, I would really recommend you this one. This looks like it's loose. Then it's just a matter of wiggle it and it will just come off. Put this one aside. Next part is the expansion port. And what I noticed myself is it works best to take off these two, these two side tabs with a bit of fresh solder. And then it's just a matter, I actually push them out because these are really hard to remove, but only with the desoldering iron or any other way. And once they're out, I suck the solder out, and then should be loose. There it is. Let's also then take out the crystal oscillator. And the contrast wheel. Okay, that one is out too. I don't see any reason to reuse any of the other parts. Like in the very early time I started with these replacement mainboards, I didn't have these brand new power cables. So I was also taking off these two. And my experience is these become really unreliable once you desolder them. So yeah, I just leave them where they are. So next part is taking off the ASIC and the two ROM chips. You only need the ASIC, but I take off the ROM chips for my repairs. I'm using a heat plate for this. It's actually just a hot air from the bottom. It's let me focus a bit better. So it's a device from Hakko. You can have here you have a little knob to control the temperature. So it's set to like 200 something degrees. So it will heat up the at the bottom of the chip. And of course, because this doesn't go that fast, you can actually heat up the entire board and take off the part with only this. But I will be using also a hot air to speed up things a bit. Once the solder is melted, I take this a vacuum pan. I will take the vacuum pan and I can just take off the chip, but you can also use tweezers or something else if you don't have a vacuum pan. This is the hot air. So with the tweezers, I'm checking how far I am with melting the solder, and I notice that I can take off like some capacitors next to the chip. So I will take the vacuum pan, and there's the chip. Using this method, you almost don't bend any pins, so that's why I prefer doing it like this. I'm doing the same with the ROM chip. And then we also proceed with the other ROM chip. Okay, that one is off too. I don't think we need anything else, so for me this board will go to trash. It was a non-working board actually, so yeah, we took all the parts we need. So yeah, one of the things to check is if the chip is really flat. So if you take the main board and you place the chip, let me focus again. You need to ensure the chip isn't, is flat on the PCB, and that there is no old solder on one of the pins that make the chip wiggle, because if it's not really flat on the PCB, you will have a really hard time soldering the chip, because then some lags will be floating above the board and you might have a bad connection, so that can really um, um, make a lot of issue with soldering it. And I think if you end up in that situation, the best is just to take off the chip, start over again, and ensure that you clean the chip in the proper way. So let's have a quick look on the microscope. I'm also going to show you how and what direction you need to mount this chip. So yeah, let me see if it's going to focus. So it's important that you can read the Sega logo. So from this side, so here's the cross oscillator, here's the connector, and the Sega logo should be readable like this. So it's written like this, so you should be able to read it. If the board is in this position, let me show you on a normal camera. So as you might see, here's written Sega, so I can read it like this. Here's Sega, it has to be in this position, similar to the original mainboard. If you don't mount it like this, it will not work. It happened to me a couple of times, so that's not a really big deal. It won't work, but you need to start over again. Yeah, so take that in account. When the chip, to position the chip in the proper way, you can really feel it with your hands. If you move it slowly, you will feel that it actually gets stuck between the pads. And because I use the vacuum pen, I don't have any bended pins, which is good. But if you have any bended pins, I can really recommend you to use the stencils I'm selling. In some other videos, I went over how to correct bended pins. So I don't want to go over it with a good chip, because then I actually might make it worse. I think the chip is perfectly taken off like this. So when you wiggle it, you actually feel that it gets in the right position because of the solder mask. And when it's in the right position, what you do is you take a little bit of flux and you apply it on the edges. See that it's there. Don't need to correct it. Then you take your soldering iron and you just dab it, and then some of the old solder will actually help you to keep the chip in place. And when you do this, it's best is to put a little bit of pressure on the chip, so it won't be floating. Everything looks good. I would say the chip is in a good position. So once the chip is in the right position, you apply a little bit of flux over the entire site. You take some fresh solder. Now and what you do is, so you put some press on the chip and you go over all the pins. Take your time, don't rush this. You might see that there are some bridges, but that's no problem. We'll fix it later. So to fix the bridges, it's simply apply new flux. You see all the bridges are disappearing. On the end, we still have some bridges. That's a problem. I'll be using a little bit of Solderwick for that. And it's out. Okay. So this side looks good. Then we proceed to the next side. It's the same. Apply flux. A little bit of solder. That looks good. It's the same. Apply flux. and a bit of solder. As you see, I'm still applying a little bit of pressure on the chip, so I know that it's flat on the board. Okay, last side. This outside pin is just a little bit. Sometimes you can also remove the solder bridge with only flux and cleaning your soldering tip. I'm using a wet sponge for that. So in that case you don't need the Solderwick. So looks like all pads are soldered. I don't have any bridges. So yeah, then of course we need to on back the cartridge board and the power and the some board cable, and then we can do a first test. I will start with the cartridge port. I recommend you to put a game in it, and it makes it a little bit easier to solder. Also ensures that all the pins remain in the right position. And then I try to align with the two holes so that slot is straight. Also for this cartridge slot, I'm using a bit of track soldering. But you can also go over them individually. It's just what you're used to. everything looks good. The power and the soundboard cable. I think this is something you need to pay a little bit of attention to, because you might see here is a pin 1 indication, and also the cable has a pin 1 indication, which is this little cut here in the connector. So that little cut goes into the pin 1 like this. Same as for the soundboard connector. As you might see, here is the pin 1 indicator, and here's the little cut in the connector. So the connector goes in. Like this. See if we can get a might see that there are like some contacts here, the same as on here on the bottom side. I'm going to solder them. Of course, we also need the LED and the crystal oscillator. For the crystal oscillator, it doesn't matter in what direction you mount it. It can be this way or the other way. Doesn't matter. For the LED, it actually also doesn't matter, but it will be red when the longer LED is in the hole here marked with an A. So here's a little here's a spot for the LED, and you see this hole is marked with the A. If you take the longer LED in the hole with the A, it's marked, it will be red. If you put a short leg in it, the LED will be green. So it actually, direction doesn't matter, only when you like the original red color, then I would recommend you to solder it like this. Okay. I think everything is now soldered in place. So I'm going to connect the power board and the sound board to give it the first test. See if it works. As you hear, we have the Sega sound. So this board looks like it's working. I'm also going to test it with a BennVenn screen. Let's see if we also get an image on it. So we actually, there are 2 connectors or 3 connectors on the board. This one is used for the BennVenn screen and the GGLCD. Also for the Chinese McWill clone, I have an adapter board for that. And these 2 connectors are for the RetroSix Cleanscreen. I will show you later. Let's first see if we get an image. As you see, we get an image, so that's good. If you have a BennVenn screen, you also need to bridge these two tabs to make the brightness work. So right now I actually don't have the wheel mounted on it. The brightness is just set to maximum. Yeah, maybe it's good to show you the other options we have. There's the RetroSix clean screen. I actually think currently when you buy it, you get a newer version. It looks a bit different. But yeah, this one works for me. I have them. As you see, I just connected two ribbons here. Let's take a LCD screen. Yeah, you don't see anything because we didn't mount the brightness wheel. So let me quickly mount the brightness wheel. I actually saw an image. Okay. Now you see the image, and the brightness also works. I have a similar kit for the Chinese McWill. So this one holds actually an adapter board I made. I will do a separate installation video for this, but yeah, it has some headers to connect with the original board or the but I can show you that it also works. So for this, I'm using the combination of the connectors for the clean screen and for the advanced screen. Ah, I always have a little bit of a fight with these kits. The LCD connector. Let's see. The LCD is not mounted. Ah, okay. So this came off. I think I will replace the connector. I will show also in another video that works. It works. I've seen it working. Yeah, I think this also shows like, yeah, these are the Chinese quality you're buying. They're cheap, yes. I prefer using one of the others. So let's get back to the BennVenn board. So for the BennVenn board, we need to connect this little solder tab. It will work without, but you cannot control the brightness. So bridged it, and as you see, now we can also control the brightness. So I think the installation is complete. So the next steps will be to assemble this board in a shell. I would also recommend you to clean up the flux. Use some. I usually put the board in a little container with isopropanol alcohol, and then I scrub it a bit with a easy brush. Really, like, buy one of these. Don't use a normal toothbrush. I think the €1 or €2 on AliExpress, but they might save your electronics one day. So yeah, to clean up the board, and then I will mount it in a shell. I hope you enjoyed the video. If you have any questions, just leave a comment under the video. Thank you for watching. Okay, yeah. So one short bonus video. I actually swapped the connector of the Chinese kit because this little lid broke off, so it wasn't holding the LCD anymore. It could be my fault. You decide. So I replaced it. I removed the connector, replaced it with one of the connectors I'm using for all of my boards. So that's the on the back. It has this locking mechanism, so not on the front. I use them everywhere, as you see. I really like them. So I have one of them. I actually have a few of them laying around, so I swapped it. And no, let's see how it works. So there's actually, as you see, there is a adapter board placed on top of the Chinese kit. And as you see, this one also works. Brightness works. In another video, I will show you how to solder this one. But it is for me very important because I can quickly test my boards if they work with all the LCD kits. I also have one for the Japanese kit. So this is the GGLCD kit. I made a similar board for it. So it's an adapter board that goes on top of the board. It has some headers. See, it's like a sandwich of two boards. And then it yeah, on this one you actually have the LCD connector on the back, and you mount it like this. It only uses the BennVenn connector, but there is a little butt on this board. Can actually show it because this board it only uses a few pads, and it doesn't use the pads I'm usually soldering. It uses the CL2 and the C-Sync. Well, a lot of these boards use the DW0 pad. Yeah, so this one doesn't use the DW0 pad from the ASIC. So it only uses CL2 and the C-Sync. And on the BennVenn connector, I don't have the C-Sync connected. So you either need to manually connect it. So yeah, or I have another solution which I will show you in a different video. But to overcome that, I created a little pad here to connect the C-Sync. So maybe it's good also to show you this board that also works. So it just connects to the BennVenn connector. So CN5. And then you need a little wire to connect the C-Sync. You can connect the C-Sync from one of the test pads. It's the pad almost on the left, marked with CS. See, also this one works. As far as I know, there is no brightness control on this, so it's just like this. Use an IPS panel, which I think is nice. I didn't change any of the other settings. I think for a dual ASIC board, but there's a single ASIC board. You also need to change the pad on the GGLCD PCB. But as you see, this one is also working. So the mainboard kit now supports a ribbon installation for the Chinese McWill clone, a ribbon installation for the Cleanscreen from RetroSix, and also a ribbon installation for the BennVenn kit. Thank you for watching.